Okay, yay for new calculus stuff. All right, today we're going to talk about the chain rule. And the chain rule is very important because it allows us to take the derivative of a lot of other different types of functions. Right now, you know how to take the derivative of everything on this left-hand column. Okay, but if we modify it just a little bit, instead of y equals x squared plus 1, if it's the square root of that whole quantity, x squared plus 1, all of a sudden you don't know how to take the derivative of that, and you're going to have to use the chain rule. We know how to take the derivative of just sine x, but as soon as the argument is anything other than just plain old x, you have to use the chain rule. The quantity 3x plus 2, that's fine, but as soon as you take that whole quantity and raise it to a power, we need the chain rule. And then the last one is kind of the same thing as the second one, where your argument is something other than just plain old x. All right, so the chain rule allows you to take the derivative of a composite function. And believe it or not, these are all composite functions. And a composite function is the function can be broken down into f of g of x. Okay, we've spent most of our time in Algebra 2 and pre-cal where I've given you f of x and g of x and asked you to find f of g of x. Well, now we're going to kind of go the opposite direction. Anyway, the derivative of a composite function is f prime of g of x times g prime. So if all of the x's are confusing you here, you can think of it as f prime of g and then times g prime. And that's something that you're going to have to know, and you're going to use it enough that you'll know it. All right, so given that h of x is 5x squared minus 4x plus 3 all to the fourth power, and I want to think of that as f of g of x, first thing I need to do is identify f and g. Well, g is kind of the inner function. So whatever's in parentheses, that's what I'm going to let g be. So I'm going to let g be 5x squared minus 4x plus 3. Now, what would f have to be in order to find f of g of x and have it equal what I started with? X to the fourth. Good. F is kind of the outer function. It's that whole clump of something to the fourth power. And if you think about doing f of g of x, then that means you put g of x in for your x in the f equation, and that's what you end up with. Okay, the next step is to find f prime and g prime. So f prime would equal what? 4x cubed. And g prime is 10x minus 4. Okay, so by the chain rule, h prime of x equals f prime of g times g prime. So I just need to plug these things into the formula. So f prime of g means I'm going to take my g and plug it into f prime. So 4, and then I'm going to plug the g in for my x. 5x squared minus 4x plus 3 all to the third power. And then times g prime, and g prime is 10x minus 4. F of g of x. G is kind of considered your inner function, or what's in parentheses. So what does your gut instinct tell you that g could be? 3x squared. Good. And f is the outer function, tan x. Good. All right, f prime is secant squared x. G prime is 6x. So I'm looking for f prime of g times g prime. So f prime of g would be what? Secant squared 3x squared. And then times g prime is 6x. Personally, I like for coefficients to go in front of the secant squared, but you don't have to. You could have written times 6x. All right, so those are the first two examples, and I kind of wrote out the steps for you. The next few, I did not write out the steps for you. And I think there are more examples on here than we're actually going to have to work, so this is not going to take as long. First off, I would suggest that we write h of x as x cubed plus 2 to what power? The 1/2. Good. All right, so if we want this to be f of g of x, what's g going to be? Yeah, the x cubed plus 2, the inner part. And f is going to be x to the 1/2. Right. All right, take both of the derivatives. So g prime is 3x squared. F prime is 1/2 x to the negative 1/2. Don't worry about that negative exponent. It's fine to have a negative exponent. Okay, so I'm looking for f prime of g times g prime. So f prime of g is going to be what? 1/2, and then the x cubed plus 2, the negative 1/2, and then times g prime is 3x squared. And we should label that as h prime because what we've done is taken the derivative of h. Y'all ready to do 4 on your own? Need to get those trig functions, the derivatives of the 6 trig functions in your head. You don't have to rewrite it. The one I can't get, my algebraic guilt that I cannot get over is times a number at the very end. But if y'all can get over it, that's great. You're already over it? Yeah, most people don't have too much trouble getting over it. All right, we're going to skip 5 and 6 then. All right, let's look at number 7. All right, what do you want g to be on number 7? Good, sine x. Therefore, f would be cosine x. So g prime is cosine x, and f prime is negative sine x. Okay, so f prime of g would be what? Negative sine of sine x. Kind of weird, but it works just like all the other ones do. And then times g prime is cosine x. Good question. The question was, will that be negative sine squared x? No, because right, it's the sine of sine x. Sine x is the argument, so instead of just an argument of x or an argument of 3x, the argument is sine x. If it had been sine x times sine x, then yes, that's sine squared. But there's nothing you can do to simplify that, even if you wanted to simplify it. Number 8, we could use the quotient rule. if we wanted to. Or we could rewrite it as 2x plus 1 to the negative 1 power and use the chain rule. Your choice. It doesn't matter. Personally, I hate the quotient rule. I don't know why, but I hate the quotient rule. So I try to avoid the quotient rule at all costs. But whatever floats your boat, I'm cool with. All right, that being said, I'm going to skip number 8. Okay, now, I went through all of this because you need to understand the process of that and understand that the derivative of f of g of x is f prime of g times g prime. But there is a little bit of a shortcut when you're just working problems. And that shortcut is if you're taking the derivative of something to the n power, and I didn't use x there because it's more complicated than just x to the n, think of that u as a chunk of something. So you're taking the derivative of a chunk to the n power. Well, that derivative is n times the chunk to the n minus 1 power, just like we know with the power rule, but then you have to take the derivative of that chunk. Okay, let me show you what I'm talking about. For number 9, we want to rewrite this as 4x to the 5th minus 7x squared all to the what power? 4/3. Good. Okay, so using the power rule that's kind of incorporated with the chain rule, I'm going to use the power rule with this chunk to the 4/3 power. So the 4/3 comes down in front. What's in the parentheses stays exactly the same. Nothing changes. And what's the new exponent? 1/3, right. Just decrease 4/3 by 1. All right, then I have to take the derivative of what was inside that parenthesis, or that chunk. So the derivative of what's inside the parenthesis is 20x to the 4th minus 14x. All right, so had you gone through the whole f prime and g prime thing, you would have ended up with exactly this, but it's a shortcut. If you prefer to use the f of x, g of x, f prime, and g prime, knock yourself out. I'm just providing a shortcut for those of you that can see it and are willing to know the shortcut.